Done. Great. Now we are live on YouTube. We have start recording, and this is the last session of the workshop. In this session, we want to go through a fast introduction to biomorpher as the most different optimization plugin in Grasshopper. And then we are so uh, interested to hear from you and your optimization problems. So, for moving forward, because that you're now a master in optimization and you are now familiar with simple optimization problem with simple forms, I just want to make this form a little more complicated. Because I want to show, we talk about user fatigue. Yeah, you remember about the user fatigue we discussed later. I want to show you how it would happen, the user fatigue. Here in the form that we had here, it was kind of simple. Like you see this cylindrical this way, and like something like this hyperbolic and parabolic forms like this. Yes, it's kind of simple. What if our form are so complicated that when we scroll over that, when we orbit over the form, we see different shapes in different viewports, like this one. You see? This is not simple to compare anymore, or I can say at all. If I, oh yeah, this way I think you can see this better. You see? In each viewport, it has its own curvature, and it is really difficult to just compare and choose between our phenotypes by just scroll around or orbit around them, because these type of phenotypes and mostly the type of forms that we are working as an architect is much more complicated rather than a cylindrical form. So for generating this form, I have three polygons with four segments here, and these are my polygons. These are my rectangles with four segment, yeah. And then I can change their dimension the same as we did with a circle here, here, and here. And so I can change their heights. This is the last one. This is the middle one. And I just add a twist, a torsion, a rotation to the middle one. You see? The middle rectangle has a little rotation like this. So when I loft these three together, you see this little bit of complicated and complex form. Let's make it less complex. And I think this is what I'm going to. So I don't want to give the rotation to the optimization algorithm. I don't want to define this as a variable. I just want to make the form a little complicated like this. So that's it. Let's move forward to see what we're going to do with this form. Now that our form is a little more complicated, let's see how we can handle this. The optimization problem, the objectives are the same as before, volume and area, and I want to make both of them minimum. So this is a minimization optimization problem. I want to make both of them minimum. But this time I want to use biomorpher. You know, if I were to find biomorpher in the main menu, in the params menu, it is somewhere here. Let me maximize my grasshopper. Yes, here. We can find this under utilities. So this is the biomorpher, and let's see how it works. Biomorpher, the biomorpher optimization algorithm is different with the other optimization algorithms based on that it use clustering as the function of choosing forms. In other words, do you remember we see clustering here in our Wallisy output here? We had here unsupervised machine learning called k-mean clustering. This function, this algorithm is exactly the same algorithm that a biomorpher use. And if you remember what the clustering do, I said 9 and 2. It's those kind of classification. And we see that the advantage is that the center of the cluster can be a representative of all of the other items in the cluster. So biomorpher use this advantage to let the architects interfere during the optimization process by choosing the form they want. I'm going to simplify it this way now, for now, and then we will go more advanced with mesh color. So for now, this is our genomes. These are geometry, and the performance means the objectives. You see that these are different terms but have same meaning. So this is a clustered oriented optimization. Let's see how it works, then we will explain more. So now you are familiar with these terms. You know what is population size. I want to put it on 50. You know what is crossover and mutation, and you know if you want to change these variables, you should know more about algorithm and how crossover and mutation works in this algorithm. So this is the k-mean clustering algorithm that it use for optimization process. Just tick that I want to show all 12 clusters centroid in the history, disable no, and mute elites. This is a more advanced uh, terms that we're not going to go through in this workshop. But let's go. Here it says, do you want to start optimization? As you know, the first generation, the first parents of each evolutionary algorithm is totally random. If you remember our stories about giraffe, we don't know when the very large giraffes made. We don't know when they really came to the world. But we know that there was a very main population that sometimes live in a jungle. Then those all stories happened. So for any evolutionary optimization, the first generation is selecting totally random based on nothing. And after that, they compare based on their fitness and evaluation. After that, we can say, okay, the generation number one is better than the generation number zero. But generation number zero does not have any generation to compare with. So it is totally random. It is not better than anything or anyone. So what the algorithm asks you here is, do you want me to select randomly myself, or do you want me to go with this setup? This does not really make a big difference in some simple optimization, but when you run optimization multiple times, it's better to go random. But if it is your first time, or if the optimization problem is super simple like this, you can just go for current. It really does not have a huge effect on your optimizations. So let's go random this time, and there we go. Now you're familiar with these diagrams, this is clusters. So what biomorpher do is that it will cluster all of the optimization, all of the generations to 12 from 0 to 11 to 12 cluster. It always go for 12 cluster. You don't have any control on it. It always goes for 12 cluster. Then it will show you the center of the cluster, the center of each cluster, so you can see the forms here. So in next steps in design, these are the center of each cluster that represent the form of the other items in this cluster. So it's want to tell you that the other items in the cluster number 0 look like this, the others are look like this. But let me tell you something. It does not mean that the other uh, items in this cluster has similar shape or similar geometry. They just have similar fitnesses, because the clustering in the biomorpher are based on similarity in fitness. So how biomorpher cluster different items, different solutions is based on their fitnesses. So those that are have more similar fitness, they are in one cluster. The other one that has different fitness, they are in the other cluster. So it doesn't mean that all of the forms in this cluster are look like this geometrically, but similar to this based on their fitnesses. And here you can define that do you want to maximize or minimize each of these fitnesses. So we don't need to go 1 over volume anymore. Let's get back here and delete 1 over volume. We can just input the volume and we don't need to call them policy optimization anymore. And let's start over. Unfortunately, this does not save data either. The only component that saves data when you close it is policy. Okay, again, go random. Oh, I want to go for 50 because this is my mind setup. So 50 is what I always go to. Now, here you can see that I can set, I want to maximize the area or minimize the area and maximize the volume. So I have this choice here. Now, the thing that I want to mention is the color coding. You get this dark circle is area, and this I say beige circle is volume. So the thing that you can show here is that it want to tell you that this cluster has large area and very small volumes. So all of the phenotypes, all of the solutions in this cluster are similar to this. This is the similarity, not the phenotype, not the geometry. If you want the geometry to be similar, now you know what you should to do. You should to add some of the something from the geometry to the objective, like the height. If you want to maximize the height, then you can input the height as an objective for maximization. Then it will add to the clustering, and then you can set that this cluster has like maximum area, minimum volume, and of course another cycle will come here and tell you how it looks in the terms of height. But for now, this is what we have. Now, the other control that you have in biomorpher is you can evolve or generate one by one. If you remember in the other components, we should tell the components that how many generation we want to go, how many generation, how many times is we want it to go to the cycle of optimization. But in biomorpher, you can just go one by one. It is really so artistic. It is like a relaxed optimization plugin. It said, okay, no rush. Do you want to see them one by one? I just let me push this button and you see, yes, I just go 150 population, cluster it for you, and you can just go and review and see if you like it, if you don't like it, if you want to change things in the middle. You can go one generation from this setup, and then now I have the chance to change the setup. Okay, let's go the next generation, this time minimizing this, maximizing this. Does it work? Yes, as a chart. You see, it's just like an artistic relaxation optimization that consider about the user more than what it got in the numerical value. So as I mentioned, it is good for user that can, and also the user can interfere. You can choose one of these form that's is your favor based on your favor. You see, I said this form is beautiful. Okay, I said okay. Next time you want to evolve, next time you want to make children from this one more. I don't care if it is if the area and volume is as minimum as it is, or as it. Okay, let me say another way. So we can just say I don't care about the fitnesses. I don't care if it is minimum or maximum. I just love the shape. You see? Let me explain it better here. Get back here. If this is the Pareto front, when our algorithm got here, like look at this line, when an optimization algorithm is going to compare these solutions, and decide which one it should take to the next generation, it will see that this one has higher fitnesses, this one has higher fitnesses, so these should be omitted, and this should carry to the other generation. Yes, this is not the same for biomorpher. In biomorpher, it says, okay, I run the optimization and I know that this one is good, this one is good, and this one is good. And I want to choose these three to get them to the next generation. Now, what do you think? And the user can say, okay, those are good, but I like this shape too. Add these and take all of them to the next generation. Make children from this one as well. And also, what about this one? I love this one. You see, this is the maximum one, and we are going to go for minimization. This is not good in terms of values. But whatever, I like the shape, so make children from this one too. So this is how we interfere the optimization process only in biomorpher. As a result, Walicy, Galapagos, and other plugins that do not let the user to interfere will get you a more accurate result in the terms of values, but biomorpher will output much more variation in the form. So maybe I can say that biomorpher is great when you want to explore the forms and when the fitness or the value of fitness function does not affect your decision. So let's go on. This time I want to select these two. I don't care if like let's check this one. This one has maximum area. Yeah, you see we have very big circle here, so the area is big, the volume is considerably big. I want to choose this one. Okay. I know these are not minimum, and I know I ask you to go for minimization for both of my objective, but whatever. I love this form. I love this form. So while you are trying to minimizing or choosing those solutions that has minimum area and volume, also add some children's, some forms, some phenotypes from this form for me. Let's evolve. And there we go. And let's see history, next tab. In this tab, we can see that how it's trying to minimize, how it's trying to optimize our problem. And also it explained that the performance optimization run shows in the red, and the other one that we select, you see in the generation number two, we select two of them. It just keep the history that which one or which are the best form and which one we select for him to for these to generate more. This is just the history of what happened during each evolution. And if you double click through each of them, you can see them in the Rhino viewport. You see here, double click. And also you can save a PNG. You can just get a name and save a PNG here. And let's see what is the output of the plots. This is a very beautiful plot. This is the generation. This X is the generation number. So generation number 0, 1, 2, and 3. And it plotted the amount of the fitness in each generation in the X, Y, yeah, in the Y axis. And also, this is a middle line for the mean of the fitness as fitness 1 and mean number or mean values of fitness 2 in each generation. You can replicate the same charts in the giraffe because we have line plot, we have a scatter plot, and you can have the same chart or plot in the giraffe, but there is no output here. You see, we cannot output any JPEG, any PNG, any PDF, nothing. You can just screenshot this chart for yourself, or you can use giraffe to have a similar chart on your Grasshopper canvas, and you can save it in any format you want. And also it has the option to draw a scatter plot from area, volume. This is the scatter plot, similar to Pareto front. But again, there is no output. You can just visualize what you see here. There are no numbers or values here or here. So you can just see what you see. And there we go. The only more interesting thing that you can add to biomorpher, because as I said, the set of the mind of the designer of this plugin, I guess, is so artistic and so consider about the form and the phenotype and the user and how user can control and interfere the optimization process rather than getting a very accurate output of the fitnesses. The other thing that you can add is the color. You see, when we seen the color in the clusters and in the plugin, they were all like some dark color or some very gray simple color. If you output the geometry, if you input the geometry to a mesh, and then add a mesh color, the way we add a mesh color. This is mesh color, this is a RGB color. RGB color starts from 0 to 255 for R, for G, for B, and for A, the transparency or the opaque. So if we want to make an RGB color and if we want to have the variety that we want, I just made a gen pool and input the gen pool to A, R, G, and B of the RGB color. Now, when I change the gene pool, you see that I can make very different colors here. And I input that to the colors of mesh color. Now, instead of inputting the geometry itself, I input this mesh color geometry to geometry, and I also input these gene pools that change the color to genome. As you know, it does not affect our optimization process because changing these gene pools only change the color of the mesh. So I just input this to the genomes because I want the algorithm to change this whenever it runs for an optimization, the same that it changed this gene pool, my variable, form variable. So this is just something that we do for have better visualization. It does not affect our computational design or anything in our optimization. So let's see how it changed everything. Go random, show all centers, and there we go. Here you can see that it's trying to give us much more colorful output. This is just for visualization. It does not affect anything. It does not mean anything even. But if you try to weight these numbers with the like geometry height, so you add a geometry height, multiply the geometry height to any of these, then here you can say like if I have a dark color, it means that this cluster has a higher height. And if I have a light color, it means that the cluster has lower height. You can color coding. You can go for color coding if you add some if you multiply something to this, if you add something to this color, so you can go for color coding. But the thing that I set up now is just for visualization, no color coding. And that's it. That's the interesting thing about the biomorpher. And the only output you have is this one. This is the biomorpher output, and you can just, how to work with this. You can just set up generation number 0, 1, 2, 4, and then you can set up which solution you want. These are the solution. Again, you can use this for if you want to make an animation or something, because we don't have generation number 1. You see, we just go for 1, 2, I think 3 generations, or maybe even 1 generation we just evolve. So yes, only 1 generation you have. And these are different solutions of this generation. But again, no output. Let me see if I can bake this one. I guess we not even baking. Oh my god. Cannot even bake the solution. What about here? Nothing here. Here? Nothing here. So yes, keep everything like a secret for itself. No baking, no output, just visualizing. Yeah, looks like that. Yeah, and the solution is system generic. We do not have access to any solution. So yes, I think that's all. So this is very amazing plugin, really artistic and really consider form and the user experience and try to make the optimization process interactive, but the result is not really accurate. And also, I have just figured out that we cannot even bake the result to have them here. I'm not sure about that. I should search more, but that's what I see here. Policy, in contrast, has a lot of control, but in the terms of numbers and values and charts and plots on the output of the optimization problem, and also since it's really well organized, the output data we could do we could go much more exploration. We can dig much more values and much more things in the policy, in the output of the policy. But you see that the policy analytical, the disadvantages that policy analytical has was that if you remember, it's just visualization. That does not give you any number, any value, anything to evaluate persistently. And Giraffe, in contrast, you just focus on data management, will give you many control over numbers, over values, over anything you want to see or anything you want to report from your optimization problems. Okay, I think that's it. Let me get back to the chat, to the session, and see if there is any question and if there anything I need to explain more, or if there anything you want to ask from your own projects. I'm all yours. Okay, thank you, Sanas. I am confused about the mean. Would you please, what is it in the optimization charts? Oh, that is the fitness mean value. If I understand your question correctly, let's see. Do you mean this one? Yeah. Let me select. Oh, draw. Is ST value trend line or mean value trend line? Is this what you are asking? Yes. This is the mean value of the fitnesses in each generation. So let me show you here. If I want to set in generation number like 9, the solution number 5. Or what if I go for 19, the last solution of last generation? And I said select, you see that it says that this is the mean value of the fitness. This is the area, and this is the volume, and this is the top circle area. This is the mean value of the fitnesses of this solution. You see, let's go for solution number 15. Again here, solution number 16. It is again here. That's why it's called mean value. It is not the exact value of the fitness of each solution. This is the mean value of the each solution. And the mean is based off generation. If I change the generation, if I say generation number 8, we can see that it totally changed. That's it. So was that clear? Did I answer your question? Hopefully. So any other question here?
Yes, for the three optimization tools that you show us, the Galapagos, the Wallasey, and Biomorph, do they have any differences in terms of the performance for finding the solutions?
As I mentioned, Wallasey and Galapagos, they are much more reliable rather than the biomorpher. I don't mean that biomorpher will mislead you, but I said biomorpher does not make for, if you want to go like for 50 generation, but biomorpher, and you have a complex problem, a very like huge computation, it definitely will crash. It does not make for that purpose. Does not make for a huge optimization like Wallasey. In contrast, the Wallasey is just made for huge computation, for heavy files. It uses a parallel computational techniques, and it is so fast and so accurate. And also, Galapagos is good, but as you know, Galapagos just accept one fitnesses, so it is single objective optimization component. So because of that reason, maybe Galapagos does not use as much as Wallasey do, but they both have accurate result. Also, the result of biomorpher is accurate, but when you go for 1, 2, 3, 5, 10 evolution, when you go for more and when you have a huge computational, it cannot follow. Unfortunately, it will crash.
Thank you. And another thing, when we use the Wallaces, we have you show us the way that we can visualize the results and look at at the front thing. But that is what you show us is for the two dimensions, the parameters. What about if we have like a four or five or even six dimensions? How can we what would be a suggestion for visualize or even be able to look at the result itself?
Unfortunately, in Giraffe you can't. In Giraffe and similarly in any Python library like Matplotlib, you cannot go more than 3 dimension. But in Wallasey you can actually. Let me show you here. Let me add more like another one here. You see, so we have x-axis, y-axis, z-axis. Let's calculate another area, the ground area. Which one? The ground circle area, this one, yeah? The bottom circle area. And let's see what happened when we add more than 3 objectives. This is G circle area, ground, or oh, if that's top, let's say it is bottom. And input that to the objective.
I think
First, let
you have to change the input from point to area. Yeah, the input to the yeah that one that area that component area one yeah the yeah on
okay,
your mouse the last one you use the central point instead of the area on your left.
okay, let me check that again because
Yeah.
couldn't follow. So this is the bottom circle, yeah, isn't it? Okay, let
Now
me,
you use the point instead of area.
okay. So this is the bottom circle area, yeah,
Yeah, that one. You need
and an
to
input.
output the A. You need
Oh,
to output the area.
yes, thank you,
Yeah.
thank you, thank you. You really saved me because it crash easily when you input something rather than value. Thank you, that was important. So let me check area, number, everything is set. Yes, all of your number. Yes. Let's go for this. 2010 is good. Let's start. See here. We have 4 fitness functions. It will map the other axis here. You see? Oh, how can I show you this way? Here. Fitness object for BC area. Smaller is better. It's said that you like it is
Oh,
minimizing. You see?
I see. I
It
see.
map it here. So if you imagine a cube, so you can have 6 maximum to 6 axes. So it will map all of the exists here like a cube. But after the sixth one, it will not map anything here. You cannot follow by looking at the axis or anything else. You should just expand your imagination. Of course, no other calculation can go more than can show more than six axes. So that's how it goes.
Yeah, this is probably good enough. Thanks.
You're welcome. Great. Thank you. Thank you for following up and asking very good questions. Another question. Okay, here I have another one. I understand that population and generation will affect our study to find the best solution. Yes. The more population, the bigger chance we get better study and the best solution. But of course, it will also affect time and also depends on our computer performance, definitely. From your experience, do you have any suggestion as how many population or how many generation would be ideal? I cannot say it will be ideal, but I can say just first I should mention that because the uh, any evolutionary optimization algorithm has some random calculation. Even the mutation will be calculated based on some random function. So any evolutionary algorithm, no matter it is genetic algorithm, it is evolutionary system, whatever it is, any evolutionary algorithm will have some random calculation, will have some calculation based on random functions. So because of that, you should not trust an optimization result if you just go for one-time optimization. So if you want your output to be trustable, to be reliable, you should go run one single optimization at least 10 times. And I really mean that at least 10 times. Especially, you mentioned something here that if the population is bigger, the result will be more reliable. I want to say that there is something, if you want to Google, you can Google that about the local optimum. There is something called local optimum because when the whole generation, let me show you here. You know, it is not always that our fitness landscape or our solution landscape are like this. Ouch, let me draw something. This is even better. You know, it is not like that all of the, like, imagine this is an maximization optimization problem. This is the absolute maximum. But we have a bit of maximum here, we have here. So since the sampling of our algorithm, as I mentioned you, is totally random, especially in the first generation, it is absolutely random. What if we choose these are our first generation samples? You see here, 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 and here. Now, when it goes to compare which one is better, maybe it go for this one. Yes? Or what if I have something here? Between all of these sample, this one is maximum. Yes? So the algorithm will think that this one is better. So the next sampling or the next child will be around this sample more than the others because it will inbreed from this one more. So this is how the algorithm can stuck in local optimums and cannot found the absolute optimum. And this will happen mostly when we have a very large population. That happen more because large population can mislead. You know, I just want to say that it cannot say that a large population or a many counting generation is better or is worse. You should just find the ideal one for your specific problem. And for finding that, I suggest to go for 50 population and 50 generation. So 50 generation and each generation, you're going to have 50 parents or 50 population. 50-50, this is something very usual that we go for our first to explore our design solution and things, and then you should rerun that optimization, the same problem, the exact same problem for at least 10 times, and to see that if all of the 10 times results in similar result, and I mean similar, maybe it's not exactly the same, but it should be similar. At least like 7 out of 10 should be same, and maybe you have three different but similar result based on your fitness and your output. Then you can say, okay, I can just gradually a little add population or make population more for having more diversity. So we will increase population for having more diversity. But to say that the more population and the more generation will give us the most accurate answer or the better answer, this is not exactly correct in some cases because we have some local optimum, and this is not the only result to increase the population or number of the generation. There are some other techniques that we should do. But to just sum up and give a simple answer to the question, I said first go for 50 generation and 50 population, 50-50, and run the same exact problem for at least 10 times and see if you got 7, 8 out similar answer, exact same answer out of 10. Then you can say, okay, I define my problem correctly and it worked correctly and I can get the answer. Now let's gradually add the population and see what happened. Does it give you more diversity? Or maybe sometimes you see that it goes crazy. It just gives you some very bad local optimum and it said, why? Why when I go from 50 to 70, the answer is totally different. That's what you start. That's why I said run it multiple times and gradually add the amount of optimization and also the population. So 50-50 sounds good for me. It always works for me. Yeah, that's it.
Okay, thank you.
You're
So
welcome.
uh, I think is this where we can use the clustering? I mean that we try to grouping some results and study it and run another steps. Like, is that so?
Use clustering for run other steps. I didn't really understand the question.
Yeah. From your explanation that clustering they group the result, they group the similar results, so we can for example that if that's the better that's the potential better result, so we can have okay, so this cluster is has a good potential. So does it mean that when we start to study the cluster, it will be a good way to do it.
Yeah. Yeah, it's a good technique. Yeah, clustering is really good technique. As biomorpher, even just rely on clustering. Biomorpher evolution rely on clustering, and also seeing the visualizing the solution in the cluster the way that Wallace go for that. Yeah, it's a really good solution. And also we can go here in the Wallace and explore more about the other techniques that Wallace gives you here to explore more about your fitness landscape, explore more about what you have, the average of your fitness, the relative difference between fitness rank. This is something I use a lot because I want to know that, because sometimes when the value of your fitness are so different, like one of the values of the fitness is also from like 0 to 1, and the other fitness is goes from like 1000 to 100, I say. Yeah, 100 to 1000. So when the value of the fitnesses are really different with each other, there is a plenty of chance that the algorithm converge to one of the fitnesses and do not look at the both fitnesses, look at both objectives in the same way, converge or lean to one of the fitnesses that has the bigger value. So these are the things that you can explore or dig more in your optimization output to figure out that the algorithm do its job the way that you want. So just take a look at this one. And for the uh, unsupervised machine learning, it has came in clustering. Also, it has some uh, hierarchical clustering and some other sort of things. It has Pareto front solution. You can choose the solutions here. And also it has a null pools. I wish it has more control on nulls, but we don't have it unfortunately here because when you're dealing with multi-objective optimization, especially when you have so different computations, like you want to compute the daylighting and also the structural efficiency. When you're using multiple plugins, when you're using multiple optimization that are not really related to each other, these null solutions really helps you to figure out which plugin give you nulls solutions, give you nulls output. Because when you run Karamba and Ladybug in the same time, you don't understand and you see like here you have because this is super simple, we don't have any null solution here, but sometimes you see like you have 100 null solutions and you don't know which plugin doesn't work better, which plugin give nulls to you, which plugin cannot go as fast as the other. So in that time, biomorpher actually helps because you go evolve one by one, and you see, oh, you are ladybug. This is your fault. You give me null solutions and you made everything looks incorrect. So Wallace really has really give you good control, very fantastic control over your data flow, over your output control and everything. And yes, clustering is one of them, one of the good ones, of course. This is a good one. Yes. And let's see what Fatima asked. He asked, can you also give suggestion about the appropriate mutation coefficient to avoid getting stuck in local optimum? It's a very smart question, Fatima, but there is no absolute answer for that. It totally depends on your fitness landscape. Totally depends on any particular example or problem definition. So, for to go controlling the mutation coefficient, you need to have a very good control over your fitness landscape. You need to know your problem very good. As you see, what I draw here, this is what I draw here. You should be able to draw something like this here. If you can say, okay, I know that based on my solutions, I know that I will have one maximum here. Like this is my variable. It will change from zero. This is like a number slider. It will change from 0 to 100. And I know when the variable change like here in 50, because I run my optimization like more than 10 times, 12 times, 50 times, I see that when this number slider get to 50, I will have a maximum here, but it suddenly go to a very bad minimum when it go to 70. And then here again get back to some good maximum. Now here you can say, okay, now how can I get this absolute maximum? For this, you can find the answer. And how you can find the answer? You should go and map your solutions here. You see, for example, you have one solution here, one solution here. This always look like this. So in such a problem, I will tell you that the distributions of your solutions looks good in your landscape. So if you want to increase the mutation coefficient, it's better to be very small increase because the distribution is good. Don't make it to like do go from here to here, go from to here to here. We don't want it to jump like a rabbit. So go very gradually. But sometimes I just map the like generation, my last generation solutions. I will map my last generation solutions here. It is look like this. Then I will tell you that, okay, dear Fatima, you need to increase your mutation coefficient because the distribution of your solution is not really good. They are really focused in the local optimums. So as I said, it is totally depends on the any specific problem, any specific optimization, and also this totally depends on how you can map your solutions through your fitness landscapes and to figure out is the diversity of the solution, is the way that solution is spread over the fitness landscape is good or is not? Are they just focus? Are they just gather together in a very small area or is it distributed? If it's not distributed very well, then you will increase your coefficient more and more and more. But if it is, maybe even you want to decrease your mutation coefficient. So it depends on just you getting engaged with your optimization problem and dig more about your result and figure out which one do you want to go for. So I guess that's the answer. Good. Thank you, guys. Thank you for following up. You're welcome. You're welcome. I enjoy when I see that these smart, small questions just gives me a good feedback that you follow, that hopefully everything was clear, and that's great. Thank you for asking. So, any other question? Great. So, is there anyone whose project is ready or want to share his or her screen to show us how he or she defined his own problem? Is there any optimization problem that you want to share or ask any question about? Because this is your time, this is your hands-on practice time. So I will wait for you. No? Okay, so maybe we should finish the workshop and wait for your outputs until next week on the Friday. I will upload a sheet and in InDesign. I will design, yes, I have one in InDesign, a very simple sheet just to show you where to input, where to put anything, where to put your problem, where to put your output, where to put your charts, just for being a little, just having a little similarity for the outputs of all the participants. And I will wait till the Friday night for you to upload your final sheets. And you can just go for, you can just add some complexity and tone the examples that we do in the workshop, the super simple examples. You can add more complexity, or you just run those again and run your own optimization and run and just output your own charts. You can for the charts and for the diagrams, you can just use Wallacy. You can just use Biomorpher and get the screenshot output from Biomorphy. You can just use Galapagos and get the screenshot output the Galapagos. Or I want to ask you also consider Giraffe because this is a very new plugin and it is really important for us to hear about your feedbacks and to hear if it works good for you, if you found anything new, if you can you know that we can have multiple plots in one JPEG. So if you want to have a line plot, then add a scatter plot and then add a bar plot, all of them. But remember to flatten the input and to see all of them together. If that is something interesting you can find there, so just let us know. So it is optional to use Giraffe or not to use Giraffe, but I hope you choose to use Giraffe for your output and explanation. Thank you, Mona. I'm glad that it was informative for you. So if there is no question and no presentation, we should say goodbye, but we can keep in touch in the Telegram group. If there is any question, if there is anything you think that I can help, I will be more than happy to answer. Thank you, Adrian. Thank you for following. Thank you. How should I read? Shema. Thank you, Fatima.
Thank you.
Thank you. Thank you. Thank you all. Thank you. Have a good day. Have a good night. And yes, bye.